Welcome to part 2 of our 12-part series. If you don't know already, this series we will be looking at the fundamentals of programming and wiring, and how we can build on that to create cool things. Each of the 12 parts introduces a new idea that we can build on in the future. We have already gone through episode 1, where we looked at the setup and the Raspbian OS. The first 6 episodes will be about the basics, while the next 6 episodes will be more advanced topics. Today, we will be looking at the GPIO pins on the Raspberry Pi. This is a relatively simple topic, so let's get started. So for this demonstration, you will only need 2 things: a Raspberry Pi and assorted GPIO wires. If you didn't know, GPIO wires come in 3 types: female to male, male to male, and female to female. So right here we have a female to female wire. It is primarily used in connecting sensors to the Raspberry Pi. As you can see, it has 2 openings. Right here we have a male to male wire. This is primarily used in breadboard circuits. As you can see, it has 2 close positions. As you can see right here, we have a male to female wire. This is primarily used in connecting to the Raspberry Pi to our breadboard circuits. So before we explain GPIO pins, what are pins in general? Well, pins are anything that we can connect with our wires, like female adapters or male adapters. On the Raspberry Pi, the pins are located at the very top of the board, next to the USB ports. They are defined by their black backboards and the rods of metal sticking out of them. These are male plugins which we use to put in wires. In all, there are exactly 40 pins on the Raspberry Pi. This will be useful later. Some of these pins are GPIO. So what are GPIO pins? Well, they're the pins that we will primarily be using for wiring up our projects. GPIO stands for General Purpose Input and Output, which means it has got to do with sending and receiving data. Input and outputting is the basis on which we will be building our projects. Any GPIO can be set as an input or output. Let's first check out on GPIO inputs. So GPIO inputs are used for any type of sensor or receiving data from an external source, such as a button or a switch. For example, we have a sensor here, which is also known as a photoresistor. Using this sensor, we can detect specific light levels based on how bright it is. So first, let's set up a simple light that isn't too powerful to overload the photoresistor. This photoresistor will be detecting the light levels from this light and will send it back to the Raspberry Pi. It will detect how bright the light is and if the light has changed or not. Based on how bright the light is, the photoresistor will send back different snippets of binary based on how bright it is. The Raspberry Pi can then get these values because the photoresistor is connected to the GPIO pins, which we have set up as an input. With this, we now have a functioning light sensor that detects light from all different directions. GPIO outputs work in a relatively similar way, but vice versa. So this is an LED, which stands for light emitting diode, and it shines light in different types of colors depending on which LED you have. For GPIO outputs, we are sending electrical signals from the GPIO pins to our LED. We do this by setting up the pin in our program. We can then turn on the pin, passing current through it. This will cause electricity to flow through our wire, thus causing the LED to light up based on what we want. We can also send different voltages through the pin using a technique known as pulse width modulation. In this way, we can either decrease the voltage that we are sending through the pin or increase the voltage. This will cause the LED to light up more brightly or less brightly, depending on how much voltage we send through the pin. We can use this to create cool fading effects for our LEDs. This will be useful later for our Christmas light project. Before we go on, I would like to explain what different pin modes are. Pin modes are different ways of numbering GPIO pins, a useful feature while coding. The two pin modes are BCM and board. First, let's start with board. Board is probably the most commonly used of the two. Board pinouts are typically considered to be the pin numbers labeled in black in the center. It is much easier to understand where the pins are. BCM is the less common to know about. BCM refers to the number next to the GPIO pin. So for example, if I have GPIO 21, the pin number is 21. As I mentioned before, not all pins on the Raspberry Pi are GPIO pins. So in all, there are three main types of pins on the Raspberry Pi: power, ground, and the previously mentioned GPIO. Since I've already explained what GPIO pins are, I'll now explain the power and ground pins. So power and ground pins are relatively simple. Think of power as positive energy, while think of ground as negative energy. These two types of pins are used to power already powered circuits. So for example, for a sensor. In addition, we can use these two pins to light up an LED without code. The amount of pins on the Raspberry Pi are 40, but each power, ground, and GPIO pins have their own specific amount of pins. For example, power has 4 pins, ground has 8 pins, and GPIO has 17 pins. But you might notice already that 4 plus 8 plus 17 is not equal to 40. In fact, it's 29. So we have 11 more pins on the Raspberry Pi. But what are they if they aren't GPIO? Well, put it simply, they're subcategories of GPIO. For example, I2C, UR, SPI, and DNC. These pins are used for different purposes. To explain it further, I2C, UR, and SPI pins and DNC pins are special communication protocols between pins. They are mainly used for communicating with different types of sensors in different ways, and they're most likely more efficient for those sensors. They are more commonly used than the regular GPIO because those sensors need it. The most commonly used of these 4 types of sub-GPIO pins are SPI, which is another one of the special communication protocols as discussed before. SPI stands for Serial Peripheral Interface. This is used for transmitting serial data from a sensor to the Raspberry Pi. These sensors are usually communication interfaces, and they are highly complex, so we won't cover it too much. It is also used for converting analog data to digital data, which is a very useful feature for SPI. We'll be talking more about it in our later episodes. Another one, UART, is another communication protocol. UART stands for Universal Asynchronous Receiver and Transmitter. The UART pins are 14 and 15 in BCM formatting. They are commonly used for transmitting and receiving between a single sensor at the same time. Another one is I2C, which stands for Inter-Integrated Circuit. The I2C pins are 2 and 3 in BCM formatting. I2C is used for communicating with sensors externally through chips. It's really common in circuits. The final pin type is DNC, which stands for Do Not Connect. The two pins are 27 and 28 in board formatting. DNC pins are pins that have no use and no functionality as of now. These pins will most likely get a new feature later. That's all for today. Thank you for watching. See you in the next video.